Hello, I'm Patrick from the CMS Perugia group, and we are working on the outer tracker, which has to be upgraded in order to be operational in the new high luminosity environment with increased radiation hardness. For these reasons, the newly produced sensors, which will be later take part of the modules, become part of the modules, need to be qualified. We are performing tests on the sensor themselves, but we also have an extended quality assurance plan where we have incorporated some process quality control measurements on the test structures on the half moons at the peripheries of the sensors. Over there, we want to get access to parameters that cannot be tested on the sensors themselves, and we would like also to perform potentially destructive measurements. Everything is going well so far. All our measurements are well within our initial expectations. Everything is well within the predefined limits, and we are expecting an excellent performance of the sensors inside the CMS detector.
I am Shaima Abouzeid. I'm working with GMM detectors. This is one of the newest gas detectors when we use this one with CMS experiment. And I have responsibility to design the low voltage power system, which is crucial and very important to power the electronics of the detector, so the readout of the detector. My design process is to use less number of the electronic devices used for the low voltage, and with that we will use low budget, money budget to buy a lot of devices, and this also is very important to keep the space that we need for installation smaller, and of course less low consumption, which is like be friendly more with the environment.
Hi, I'm Milos, and I'm working on AGCAL electronics test systems. So the main motivation for what we do here is we try to take a miniature slice of the detector front end, and we put a miniature placeholder of the detector back end, and then we try to test all kinds of data exchange that exists between the two. Once we do this, we will be able to move towards horizontal scaling, eventually building the detector. This is the setup. Here we have the back end of the setup and the front end of the setup. And the various kinds of data exchange that we try to test for are timing distribution. For example, the backend sends a precise clock reference to the front end, which is there then recovered. Regarding fast control, we are able to send a variety of fast commands from the detector backend to the detector front end. And regarding slow control, we can configure all of the front end chips from the DAQ backend. Lastly, we are able to configure the readout chips that exist in the front end to send out data patterns, and then these data patterns we bring back to the trigger backend where it precisely meets our expectations.